Alright, so let's go ahead and get started. First off, I'm going to go File, New Scene, and here we are in a new scene. And what we need to do is we need to come into our scenes. I've got a folder set up here called Beginner, and we need to create an object, a material, and a shader. So if I just go into Component, Game Object, sorry, Create Other, and a capsule, this will be our demo capsule. So right now we have a diffuse shader on it by default, but we want to create our own shader. So you can see right there, the mesh renderer, default diffuse assigned to it right now. What we need to do is right click in here, go Create, Material, and I'm just going to call this one here 1_flat color. And we just click and drag onto this, and you can see that it is now using one flat color. Alright, so there's no change at the moment. This is still a flat diffuse, or it's still a diffuse color. So what we need to do is we need to create our own shader. So I'm just going to go Create, Shader. I'm just going to call this one here the same, 1_flat color. And what we can do is we can actually just come to Custom, and we can call it flat color. And there's not going to be any change at the moment. So that's how you assign your custom shaders. You just go to Custom Flat Color. But at the moment, this is simply the exact same diffuse shader. It's just one that we can edit. So what we're going to do, we're going to open this up, and it will open in MonoDevelop. Now you can use any program you like. I like to use MonoDevelop for shader writing, as it is, quite nice for working with Unity. And it's got a bunch of code in here. We don't care about this. That surface shader stuff, we've already covered that in a previous series. What we're going to do is we're going to start from scratch. Alright, so let's go ahead and write the shader line by line. So the way we do this is we write in shader, and this shader is a function which just has a couple of quotes, and those quotes encase a name. So I'm going to write Unity cookie /introduction /1 dash, which is a flat color. And just so it doesn't interfere with the example ones I've already set up, I'm just going to put a toot in there as well. So this is the name of the shader. So we just save this now. Come to Unity and refresh. You notice it goes pink. It's because nothing can be run. But in here, we just come down to Unity cookie. We have a folder called toot. And in that one there, we have a folder called introduction. And then we have flat color. So you can rename these folders to whatever you want. You can have them just appear right in the front here. Let's demonstrate this. I'm just going to come through and let's rename introduction to beginner. Come to Unity, and we can come to Unity cookie toot beginner flat color. It's as easy as that to rename them. So that's the name of the shader. It's not going to do anything yet, but what we need to do now is create something that it can do. So let's start with the properties box. So we're going to go to properties, and this is another function. In here, we can create some properties. So for now, I'm just going to write in color and call it color. So we start with an underscore, our color variable, and this it's not required, but what it does is when we're working with our shader, we'll know that the ones with underscores are variables that can be adjusted within Unity, and the ones without underscores on the front are ones that can't. So it just helps us keep track of that. Now the first part in quotes is the name, so that's what it appears as. It can be whatever you like. And then the next part is a color. So color just gives it a color picker. You can do other things here like float. You can do range, or something like 0,2. You can do a few different things in here, but for now we're just going to stick with color. And this equals, so we'll give it a starting value of 1.0, 1.0, 1.0, 1.0. So we now have a properties box. Let's jump back into Unity now, refresh. You can see we have a color. And it's coming up as black at the moment. Let's change that to white. Edit, oops, not edit, you can click reset, and notice it changes to black. So this is just because there's a bit of an error at the moment. The error is actually not, in fact, in this line. Error is the fact that we don't have a shader yet. We've only got a properties block, so there's nothing for it to do. So let's go ahead and start working with our shader. We do this with what's called a subshader. So a subshader contains our shader effectively. So you've got our main shader up here. Oh, sorry, this one. Within that you've got your properties, how it interfaces with Unity, and you've got subshaders. So subshaders, you can have multiple subshaders per shader, and within those subshaders has all the stuff that controls your shader. Now the reason that we can have multiple subshaders is you might have one for an Xbox 360, you might have one for a PlayStation 3, PlayStation 4, PlayStation 2, whatever, I don't know. But you have one of them per console that it's going to be run on, and that one shader can be run on everything, which is great. So we're only going to be working with a single subshader in this series, but that's just so you have an understanding of what it's there for. Alright, so within this we have what's called a pass. Now you don't have to include the pass tag, but we will, because we will be working with multiple passes. Now a pass is just like a render pass. You can have your beauty pass, you can have any more lights that are blended over the top, you can have a diffuse pass with a translucency pass blended over. Anything you like, you can just blend together multiple passes. So you can have like 8 different passes that are being all blended together, and that is great. So just think of a pass just like a render pass, but in real time. Okay, so we're not going to see anything else in Unity yet, so we'll just keep going. Let's start with the CG program. CG. Right, so these two tags will contain all of our CG code. So up until now we've been writing in ShaderLab. So ShaderLab is the core language that has been written by Unity, and CG program is the language written by NVIDIA. So when we start this CG program, all in capitals, if it doesn't turn orange you've spelled it wrong. So when it gets to the CG program, we're basically telling Unity, stop processing ShaderLab, start processing CG. And then when it gets to NCG, it does a reverse, it switches back to ShaderLab. Alright, so we have to have a few things in here. We have to have fragments, we have to have user-defined variables, our base input structs, we have to have our vertex function. Now this can be called vertex program, vertex shader, vertex function, all those different things. Just know they're interchangeable terms. We have our fragment function, and these are all the things we need in our shader. So it's not going to do anything just yet, we still need to fill these out. So let's go ahead and do this right now. Let's start with the user-defined variables. We need to define our color, so we go float4 underscore color. So you can see here that because we want this color within our CG, we need to define it first. So our CG code doesn't know what that is. It gets the information, but it doesn't know whether we want it as a float, as a half, as a fixed. So we have to define it, and we do that by just float4 color. Just assign it an empty variable, and Unity will sort out the rest. And do remember to put in the semicolons. You have to have a lot of semicolons in CG. It's just like JavaScript. Now the other thing is we will also write in uniform in front of it. Now this is not required in Unity. The uniform keyword is a CG specific keyword for working with CG program. Unity can ignore it, it doesn't have to have it, but uniform is used to define variables. When we're doing an initial definition, we use a uniform keyword. Because I write shaders not only for Unity, but I write shaders for things like Autodesk Maya, so real-time shaders for the viewport, I like to get into the habit of using generic things like this, so writing in uniform, so that when I want to transfer my shader to another program, I can easily do that. So we have two different structs. So we have struct vertex input, and we have struct vertex output. So these structs are just like little base classes where we can have our little functions communicate with each other and with the Unity program. So the vertex input struct, now you can call this whatever you like, I just like to call it vertex input because it's the input for the vertex program. We want to grab in the float4 vertex with the semantic of position. So what this line here is doing is our shader, our object comes with a whole bunch of semantics attached to it. So that's things like the vertex position, it has the normals, the tangents, it has the texture coordinates, so our UV maps. These are things that we can access directly from the object, and we do that with the vertex input struct. And using those semantics, we can assign them to variables. And we can use as many variables as we want. You can name them whatever you want, but that's just how we get them. So using that colon and semantic is our way of assigning that the semantic position to our vertex, and the vertex is of course a float4. So float4 of course is a XYZW, or RGBA. You can refer to it in both ways, it doesn't matter. I like to refer to things as XYZW, even for colors. You know, that's just what that does. So I hope that makes sense to you. Now, the vertex output. This is what do we want to output from the vertex function so that we can use in the fragment function. Now, we don't actually want anything at the moment. We don't want to use anything from the vertex function. We're just going to take the color straight from the properties box. But there is one thing that we have to have in the vertex output, and that is a position. We have to take the object's input position, convert it to a space that Unity can understand, return that. So what we have is we have float4 pos sv _position. So what we have here is we're going to, in the vertex function, which we'll do in a moment, we will take that vertex position from the vertex input, convert it into Unity's own matrix, and return it to pos. And Unity will take the variable pos from the vertex output, and it will use it for our model. So if we don't do that, Unity doesn't know where to place those vertices. This is all handled within the shader. So if that doesn't make sense to you, it didn't actually make sense to me when I first did this until I started studying GPUs. What happens is we have our model, and the model is not passed to Unity at all. The model is sent to the GPU, and the GPU, our graphics processing unit, will take that model, it will read out those positions to that POS, and it will send that back to Unity. So that's how Unity knows where the object is. It's not reading from that object at all, it's just taking what the GPU gives it. Alright, and the other thing is SV position. So you're probably wondering why we don't just use position. Now if we use position, this will work. However, SV position is a change that Microsoft decided to do with the update of DirectX 11. So if you're writing any shaders that you want to work in DirectX 11 mode, you're going to have SV position. Microsoft decided to change it, and when they did, they broke everyone's shaders and everyone got a little bit pissed off, but that's just what happened. So that's just why we're using that. Okay, so let's move on. Let's take a look at the vertex function. Now, functions within CG, they work a little bit differently to JavaScript, well, they're pretty much the same, but they have this unique way. What we do is we write vertex output, which is the struct name, and then we call the function, and in here we're going to write vertex input, and in here we have our information. So these functions are structured a little bit funny. It took me a little while to click onto how these worked. I was actually using shaders for quite a while until I actually worked out, why we're using it like this. What we have is we have the vertex output. So the vertex output that we see, this is what we are writing to. So we are going to be taking the vertex input. So vert is our function name, by the way. Vertex input is this struct. So we're going to be using vertex input as a base. We're going to assign that to v, so we can, instead of having to write vertex input every time, we can just write v. And then we're going to take the result from this and we're going to assign it to vertex output here. And when we assign it to vertex output, our fragment function can read our vertex output struct, and Unity can read the vertex output struct. Alright, so let's start working with this. We're going to start with vertex output O, and we're going to return O. So O is just short for output. You can call it whatever you like. I'd recommend using O because it's nice and short. So what we're going to do here is take vertex output as a base for O. So this is effectively like saying O equals vertex output, except because we can't write something like float4 because it's not float4, it's an entire class, we have to write it like this, vertex output space O. And then we just return O, and of course make sure you have semicolons, otherwise it'll break, and there we go. So within these two, this is where we process everything with the vertices. So there's only one thing we're going to be doing right here, and it's probably going to be really difficult to understand. If you don't quite get it, then that's okay. I will try and explain it the best that I can. Right, so this function will be, this line here, will be in every single shader that we write. What it's doing is it is taking our vertex position, it is multiplying it into the Unity matrix MVP. So this is the MVP. There's a bit of a documentation on the Unity wiki on how Unity matrix MVP works. I'm just going to not tell you what it means because it's just going to be confusing. It's like Unity matrix MB times Unity matrix position. Basically, what it's doing it is moving the vertex position that we get from the object into the Unity matrix position so that it can understand it. But to explain a little bit about how that multiply works is what we have. We want to take this matrix and make it work. So we have Unity matrix.mvp. This is a x, y, z, w coordinate. v.vertex is a x, y, z, w coordinate. And what we're going to be doing is we're going to be multiplying these together. So let's just, I'm just going to write out a little bit here. Now this isn't actual code, these two lines and what I'm going to write. These aren't part of the shader. I'm just trying to explain how the Mul function works because it's a little bit confusing. But it is effectively just multiplying a matrix, and a matrix is like 4 vectors in a row by a vector. So what we have is we're going to take our Unity matrix dot xyzw. This is going to be, I'll just call this 1 for now, times v dot vertex dot x, and we'll do that 4 times, and we'll have y, z, and w, and over here we'll have 2, 3, and 4. So the matrix has 4 float 4s inside it, and we're going to multiply each one of them by this coordinate, which will result in a single float 4 vector. So it's a little bit confusing, but we'll be using it a lot, and the multipliers here are mainly used to convert spaces. So we're going to be taking things like the vertex, our internal vertex position from our object, from our obj, and we're going to be converting it into something that Unity understands. We're also going to be using other multipliers, other matrices later on, where we will be doing things like converting from object space to world space to object space to tangent space. It's just used to convert spaces. And later on in this series, in this beginner series, we'll actually be learning how to write our own matrices. So I hope that makes sense. If you are having trouble understanding how that one works, then by all means leave a comment and I'll do my best to explain it a little further. Try not to look too much into it as it can get very, very confusing very quickly. At the moment, just understand that it is just a multiply function for converting spaces. Okay, so it's still not going to work. If we save this and we refresh it in Unity, it's going to pop up with a whole bunch of errors still because it can't do anything. Here we need to have a fragment function. So right here I'm going to write float4 because we don't need to assign it to anything, so we're not going to use it after this. We're just going to assign it to a float4. Vertex output, well, we're not going to use anything as a base, vertex output I, and give it a semantic color. So this is the fragment function. So what we have here is we are creating a new function called frag, and we're going to be using vertex output as the base, and we're going to be using I as the vertex output, so that means we can refer to anything from this that we assign to O as I, and we can use it in here. It's going to be very important when we deal with things like textures and lighting and so on. And we're going to be telling Unity that it's a color. Of course it is, flick 4. And yeah, that's pretty much the same as a vertex function. All we need to do is go return, and that's it. So all we're doing is we're going to be returning the color that we have defined up here, which is also defined up here. But the shader still won't work. Notice I've got this little bit up here called fragments. So in here, we need to assign some initial variables. So what we're going to do is do a hash tag, which is used for our fragments. You're going to pragma vertex vert and pragma fragment frag. Okay, so what a fragment is it's an instruction. So we have a series of fragments we can use, and what they do is tell Unity what to look for where. So what we're doing here is we're saying where are we going to look for this vertex function. Now the vertex function, we've called it vert. So if we call this one here something like Bob and Jill, we would have to write up here Bob and Jill, just so it knows where it's looking for things. I'm just going to undo that because I do want vert and frag. So that's all that the vertex of what the fragments do, is they're just instructions telling Unity what it's doing. So what's the shader actually doing? Well, we've got a vertex function and a fragment function. Here you can find them. So let's go ahead and take a look in Unity now. Now if we refresh this, you can notice that it's still not working. It's got a whole bunch of errors here. So this means that we have a bug in the shader. And what we need to do now is we need to just go through and find that bug. Alright, so the error that we've actually got here is that I've spelt output wrong. I'll just add in a T there, and that's all we need to do to fix it. I hope. There might be other errors, I don't know. So there's a lot of errors that you can run into when writing shaders. The most common ones are no semicolons at the end of things, and misspelling. So if you do run into an error like that, make sure you go in and really check your spelling. If you come into Unity here, I'll just highlight the line here. Here it is. So you can see here that it says unrecognized identifier vertex output. And it just means that it can't find vertex output. So you've probably spelled it wrong in the struct. So if we press Ctrl R to reload this, you can see that it is working fine. So we now have a little color picker. We can control this however we want. So we now have our very first shader, a flat color shader, which is fantastic. And that's all there is to it. Now there's one more thing that I would like to add to this, and that is a fallback. So fallbacks, you just write in fallback and in quotes diffuse. So a fallback, I'm just going to write it in here, fallback commented out during development. I do this by habit. A fallback is basically a shader, a sub shader that will run if no other shaders are able to be run. And we just comment this out while we're writing things so that, you know, we'll see pink when we have an error. It won't just run the fallback. So when you have your shader ready for production, you just uncomment fallback, and should your user have an error, so they can't view that particular shader, they've got a really old graphics card or something like that, it will run the fallback. So that way they don't see some bright pink characters running around, they will see some, you know, standard diffuse characters, textures, everything still on them. Alright, so that is it. I hope you guys learnt a lot in this tutorial. There's been so much to cover. It's, you know, learning shaders really is a complex task. There's a lot to it, and getting these fundamentals, learning those, is really what is important. So you need to make sure you understand these core concepts. If there's anything you're stuck with, there is the presentation is actually available. So the presentation, you can see, is just an OpenOffice Impress document. This is available in the source files. If you have OpenOffice, you can open this and click through any of these that you wanted to look at in further detail. Right, so there's also a text version of this tutorial available for you. There'll be text versions of all of the tutorials. If you can't find anything there, you're still stuck, something's just not making sense at all, leave a comment underneath this video on unitycookie.com and I will do my best to answer all of your questions. So that is all for this lesson. We have our flat color done, and in the next video we'll go through and start adding in some lighting. So my name is Alex Tilford and you are on unitycookie.com, the shader writing master series for Unity 4.